Good day everyone. In this video, we will be tackling about the solutions of oblique triangles. So now, let's move on to the definition of oblique triangle. So the simple definition, an oblique triangle is a triangle that does not contain a right triangle. So which means it can be acute triangle, that all the angle of a triangle is less than right angle. Or it could be an obtuse triangle, that one of the angle of a triangle is greater than a right angle. So as you can see here in the acute triangle, all the angle is less than 90 degrees. And the obtuse triangle, one of the angle is greater than 90 degrees, as you can see here. But take note, if you add all the angle, the result must be 180 degrees. So for labeling the parts of oblique triangle, let the angle be labeled as a capital A, B, and C, and let the sides opposite them be labeled A, B, and C respectively. So in a simple understanding, let the capital A be a alpha, let the capital B the beta, let the capital C the gamma, which the opposite of the alpha is the small letter A, the opposite of the beta is the small letter B, the opposite of the gamma is the small letter C. In solving an oblique triangle simply means that the three parts are given. At least one of the given parts is a side. And we find the remaining three parts of the triangle by applying the law of sines and the law of cosines. So in this part, this is the formulas that you need to remember. So for the law of sines, we have A over sine alpha equals B over sine beta equals C over sine gamma. So for the law of cosines, in these formulas, this is the formulas that you need to remember for solving the missing sides. So for side C, we have C squared equals A squared plus B squared minus 2AB cosine gamma. And for the side B, we have the B squared equals A squared plus C squared minus 2AC cosine beta. And for the side A, we have the C squared equals B squared plus C squared minus 2BC cosine alpha. In this part, this is the formulas that you need to remember. These formulas will be used for solving missing angles. So for missing angle A, we have the cosine equals B squared plus C squared minus A squared over 2BC. So for angle B, if it is missing, we have the cosine B equals A squared plus C squared minus B squared over 2AC. So if the C angle is missing, we have the cosine C equals A squared plus B squared minus C squared over 2AB. Take note that to solve an oblique triangle, we must know the measure of one side and any two other measures. As a consequence, any triangle problem may fall under any one of the following cases. So these are the four cases in solving oblique triangle. So case 1, given one side and two angle, SAA or side angle angle. So for case 2, given two sides and an angle opposite one of them, or SSA, side angle. So for case 3, given two sides and included angle, or SAS, or side angle side. For case 4, given the three sides, or SSS, side. Now that we know the four cases in solving oblique triangle, let us solve the problem in case 1. So side angle. Given one side and two angles. Example 1. Solve the triangle ABC given is side C 8 cm, alpha is 32 degrees, beta is 10 degrees. So this is the illustration of the problem. So we need to find the side B, side A, and the gamma. But first, let's find the gamma for us to be able to solve the other side of the triangle. So for finding the gamma, we have 180 degrees equals alpha plus beta plus gamma. So we know that the given angle is the alpha and the beta. So we have 180 degrees equals 32 degrees plus 10 degrees plus gamma. So let's transfer the gamma in the left sides as well as the 180 degrees in the right sides. You will get the 43 degrees in adding the 33 degrees plus 10 degrees. So it will become gamma equals 180 degrees minus 42 degrees. So the result is gamma is equal to 137 degrees. So now that we know what is the gamma, so let's now proceed to the finding the sides of the triangle. Let's now find the two missing sides of the triangles by using the law of sines. So we have A over sine alpha equals C over sine gamma. So copy the A over sine 33 degrees equals 8 over sine 137 degrees. Cross multiply and it will look like this. A equals 8 sine 33 degrees over sine 137 degrees. Let's solve this by using the scientific calculator, and the result is A equals 6.39 centimeter. So let's now find the side B by using the law of sines. So we have B over sine beta equals C over sine gamma. So copy the B over sine 10 degrees equals 8 over sine 137 degrees. So cross multiply and it will look like this. So we have B equals 8 sine 10 degrees over sine 137 degrees. So let's solve this by using the scientific calculator. So the result will be B is equal to 2.04 centimeter. So let's now move on to case number 3, the side angle side, given two sides and included angle. It is like similar to case number 2. However, the case number 2 is an ambiguous case, which we use the law of sines. And in this case, we will be using the law of cosines. So we have here the problem and the illustration. So the given is angle A, which is 55 degrees, and side B is 6, side C is 9. So let's find the side A, angle B, and angle C. First, let's find the side A by using the law of cosine. So we have here the 2 squared equals B squared plus C squared minus 2BC cosine alpha. So let's plot or plug in the given. So we have A squared equals 6 squared plus 9 squared minus 2 times 6 times 9 cosine 55 degrees. And we will have A squared equals to 36 plus 81 minus 62. So to solve this, we have to square root the result of A. So square root of 55 is 7.4. So let's now find the angle B. So let's use the law of sines here. So we have sine beta over B equals sine alpha over A. So sine beta equals B sine alpha over A. So let's transform it into a inverse. So we have beta equals to sine inverse times B sine alpha over A. So let's input the given. So we have beta equals to sine inverse 6 sine 55 degrees over 7.4. And we will have the result is 41.62 degrees. So to find the C, use the angles of a triangle, add to 180 degrees. We have C over 180 degrees minus 55 degrees minus 41.62 degrees, and the result is 83.38 degrees. And finally, let's now move on to case 4, which is the side, given the 3 sides. So let's solve for the triangle ABC, which is the given is side A, it's 15, side B is 17, side C is 19. So the missing in this problem is the angle A, angle B, and angle C. So let's now first find the angle A, which is to find the alpha, let's use the law of cosine. Cosine alpha equals to B squared plus C squared minus A squared over 2BC. So this is not the final, so let's transform it into inverse. So we have alpha equals cosine inverse times B squared plus C squared minus A squared over 2BC. So we have to input the given. So we have alpha equals to cosine inverse. So we have 17 squared plus 19 squared minus 15 squared over 2 times 17 times 19. So we have alpha cosine inverse times 289 plus 361 minus 225 over 646. And the result will be alpha is 48.9. To find beta, we have cos beta equals A squared plus C squared minus B squared over 2AC. Transform it into inverse. We have beta equals cos inverse times A squared plus C squared minus B squared over 2AC. So let's input the given sides. We have beta equals cos inverse times 15 squared plus 19 squared minus 17 squared over 2 times 15 times 19. So we have beta equals cos inverse 225 plus 361 equals 289 over 570. So the result of the beta is the 58.6 degrees. So lastly, let's find the gamma. To find gamma, cos gamma equals A squared plus B squared minus C squared over 2AB. So let's transform it into inverse. We have gamma equals cos inverse times A squared plus B squared minus C squared over 2AB. So let's plug in the given side. So we have gamma equals cos inverse times 15 squared plus 17 squared minus 19 squared over 2 times 15 times 17. So we have gamma equals cos inverse 225 plus 289 minus 361 over 570. So the result is 74.4 degrees.